In this video, we're going to look at examples of combining transformations. My first example is a combination of two reflections. In other words, I'm going to ask you, what single transformation has the same effect as a reflection in line L1 followed by a reflection in line L2? So to do that, we'll use our reflector. And I'm placing my reflector here. I'm going to reflect points A, B, and C. There's C prime, there's B prime, and there's A prime. And then using my ruler, I'll connect those points. And then we'll take this triangle and reflect it along line L2. I'll call that point B double prime. This will be A double prime, and that'll be C double prime. And the idea is to look at where we started, which is this yellow triangle over here, and compare that triangle to where we ended up. This is where we ended up. And what single transformation would have gotten us from the start to this finish? Now, as you're looking at that, if you're thinking it's a slide, good for you, that is a slide. So, well, I can show you. Here's my tracing paper, and that would be a slide. I have a slide, but usually what I want to do is describe that slide, so I'm going to draw in the slide vector, and I'll focus on point C, which started over here and ended up over here. So there's my slide vector. What you might notice, though, if you measure the length of that slide vector, I've got about 15 centimeters, and then you measure the distance between the two lines, L1 and L2, it's about 7.5 centimeters. You might think, and you'd be right if you think this, that the length of the slide is twice the distance between these parallel lines. So in conclusion, what single transformation has the same effect as a reflection followed by another reflection when those lines are parallel to each other? A translation. A translation where the length of the slide vector is twice the distance between those two lines, L1 and L2. Let's look at another example. What single transformation is equivalent to a translation along vector xy followed by a 180-degree rotation about the point y? I'm going to start by sliding this triangle, and again I'm going to put a little pencil rubbing at each one of these vertices on the back of my tracing paper. I'm holding my tracing paper over triangles A, B, and C. I've marked point X down here, and now I'm going to slide point X along that vector until it reaches the end of the vector. Now, pressing rather firmly, it should leave a little pencil mark on your paper, and it did. So I'm going to connect those 3 points, and this would be triangle A prime, B prime, C prime. And now I need to rotate this triangle 180 degrees. So I'll draw a ray from Y through one of those vertices. And I think I'll extend it this way too, because that right there is a 180-degree angle. So again, with the tracing paper, I'm going to keep my eye on this point A, and now I'm going to hold the tracing paper down at Y, and I'm going to rotate that triangle until point A has traveled 180 degrees. And now I'll press down on my pencil rubbings, and I'll draw in this triangle. This will be triangle A double prime, B double prime, C double prime. A double prime, B double prime, C double prime. I started over here, but I ended up over here as the result of that combination of transformations. So what single transformation would have gotten me from here to here? Certainly is not a slide, doesn't look like a reflection. It's looking more like a rotation, But remember, I want to describe that rotation, so let me see if I can find the center of rotation. It's not Y. Let me see if X. So I'm trying to match this starting point over to where I ended up. And it certainly doesn't look like X is the center of rotation. So then you try other things. And as you're watching me, if you think maybe going halfway between X and Y would work, your thinking is right again. It really does look like what I have here is, if I get that's the M, is the midpoint of XY. It looks like I have a rotation around point M. That angle of rotation is 180 degrees. So my conclusion is that I have a 180 degree rotation about point M, where M is the midpoint of XY.